Dear students, welcome to my channel Content Hub. Today I am going to explain about the quadratic probing. Quadratic probing is also one type of the collision resolution technique, and this is the subtype of the closed hashing. So what is quadratic probing and when you are going to apply? So it's a quadratic probing is the collision resolution technique. It means that whenever the collision occurs, then only you can apply the quadratic probing, otherwise will not going to apply. So quadratic means what? What is the quadratic means and what is the probing? So probing is nothing but a number of search. Probing means number of search. Quadratic means what? It means that square. Quadratic means square value. So here I have said that if no collision occur, if there is a no collision occur, simply apply the hash function and calculate the index and store in the hash table. In else part, suppose this is fail, this part is fail means collision occur. If no collision means this part is true, this part is true. If collision occur, then come to the else part, and what will you do? You have to calculate index of the given hash function plus I square modulus table size, and the table size is going to table size and I value is 0 to m minus 1 means table size minus 1. So this formula you are going to apply for the quadratic probing, because quadratic name is saying that quadratic, so you will going to check the squared index. In linearly you are immediate next you are checking that, linearly you are checking that, one by one you are checking, but here you are not going to check one by one, here you are going to check a square value. You are going to check a square value. So for better understanding I am going to explain quadratic probing with the example. So I have taken this example, quadratic probing example. Same I have explained in the linear probing with same example. Now I am going to explain here quadratic probing. So in quadratic probing I have said that will square. So first of all, one more thing I said that if it is no collision occur, then simply we do and then calculate the index and will store in the table. So in starting, look at that my table. In starting my hash table is completely empty. In starting my table was empty. Now my keys, I have created one table. Here I kept that my all keys. So 3, 2, 9, 6, 11, 13, 7, 12 keys I have kept it there. Location is nothing but we are going to calculate the index. Location is nothing but an index with the hash function. Using the hash function we are going to calculate the location. So here if I am going to use the calculate the index of the third using this hash function, then I'll get that index of the third is 9. So in starting my table is completely empty. So you can see here my ninth index is 3. So 3 is going to store at ninth index. 3 is going to store at ninth index. Now I am going to calculate the index of the second element, and if you are going to calculate using hash function, you will get that 7. You will get the 7. Go and check the table. Is 7th is free? Yes, this is free. Then what you are doing? You are getting in one time. You are getting in one time. The place is completely free. Means 2 is going to store at 7th location. 2 is going to store at 7th location. Right? So their probing is what? 1. Now this next element came 9. If you are going to calculate index of the 9, you will get that 1. Go and check your table. Is first index is free? Yes, this is free. So then you are going to store 9 at first index. Now 6th element come, and if you are going to calculate hash index of using hash function, you will get the 5. Go check that is your table free. Sorry, 5th index is free. Yes, it's free. Then store the 6. Store the 6 at 5th index. You store the 6 at 5th index. Right? Now 11 came. Now so far you have seen here there is a no collision. So far there was a no collision. So all this probing is also, the number of probe is what? 1 only. There was no collision. It means that the probe value is 1. Now coming to the 11, if you are going to calculate the index using the normal division method, you will get that 5. Now check your table. Is 5th index is free? No, it's not free. Then you apply quadratic probing. Now here you apply quadratic probing, and that I have applied here. And I say that I value is 0 to m minus 1. So I will start from I value is 0. So what I am doing, and I say that h of x value, what is h of x value is now 5. So 5 plus 0 modulus 10, you will get that 5. Check that is fifth index is free. No, it's not free. So this is first probing. Now what will you do? I increment by 1, then 5 plus I square, because you are doing the quadratic probing, it's not a linear probing. So quadratic means what? You are doing a square. So 5 plus I square modulus 10, then you will get that 6. Check that is 6 is free. Yes, 6 is free. So I am using here the different color for the 11 because 6 is free. And see, you are getting the place is in second time. And because of that reason, the number of probe for the 11 is 2. Number of probe for the 11 is 2, and 11 is going to store at what place? 6th place. 11 at store at 6th place. Right? Next is 13. If you are going to calculate index of the 13, then you will get that 9. Go and check that is 9th index is free. No, 9th index is not free. Then what will you do? Apply quadratic probing. Use quadratic probing and calculate the index. Then I have calculated 9 plus 0 square. If you do that, again you will get 0. Then you will say that this is not free. This is called first probe, first time search. Next what will you do? 9 plus 1 square, then you will get that 0. Now check that is 0th index is free. Yes, 0th index is free. So you are getting that 0th index free in 2 time. So here also the 13th number of probe is 2. The 13th number of probe is 2, and the 13 is going to store at where? At 0th index. So 13 is going to store at 0th index. Now the next element is 7. My next element is 7, and if I going to calculate the index using the given hash function, its index is also 7. Now go and check that is 7th index is free. No, it's not free, means collision occur. Now apply quadratic probing. So I have applied here quadratic probing. Using the quadratic probing, I have seen that in 2 time I am getting the place is 8th index is free. 8th index is free, means that 7 is going to store at where? At 8th index. This 7 is going to store at 8th index, and the number of probe is 2. Now the next element is 12, and if you are going to calculate index of the 12, that index is also 7. Check that is 7th index is free. No, this is not free. Then what will you do? Apply quadratic probing. Then I have applied quadratic probing here. 7 plus 0 square, 0 modulus 10, you will get 7. That's not free. This is first probe. Then 7 plus I square, you increment the I. 1 square, and modulus 10, you will get that 8. Is 8 free? No, 8 is also not free. This is second probe. Then 7 plus 2 square. Then you will get that index 1. Go check that first index is free. No, it's not free. So this is third probe. Now 7 plus 3 square. And if you're going to calculate the index, you will get 6. Check that is 6 is free. No, this is also not free. So this is the number of probe is fourth probe. Now check 7 plus 4 square. Modulus 10, you will get the third. Check that is third is free. Yes, third is free. So this is fifth probe. So total probe is what? 5. The number of probe is 5, and the 12 is going to store at where? At third index. So 12 is going to store at third index. Right? Now what will you do? Order of an element. Now write the order of the element. What is the order of the element in the hash table? So you have seen that 13 is stored at 0th index, 9 is stored at one index. Second index is empty. There is no element at second index. So that is empty. So you write it like underscore or dash. Okay. Then 12. Then fourth index is free. Then simply you put it that dash or underscore. Then fifth is at fifth index 6 value. Sixth index 11 value. Seventh index 2 value. Eighth index 7 value. And 10th index 3 value. So like that the quadratic probing is going to work. It's almost similar like the linear probing, but difference is that linearly they are incrementing by one value, but here incrementing by the square. Previously incrementing by the 1 and here incrementing by the square. Now we'll see the advantage and disadvantage of the quadratic probing. So here advantage is that no extra space. Here in the previous linear probing also this was the advantage, because they are linearly checking that a space is free or not, and if it is free they are storing the element. Here also is in square wise it's checking the free place. If it is free then it's storing the element. So it's saving that space as compared to separate chaining. Linear and quadratic both is saving the space, it's utilizing the space. Next is that the quadratic linear probing was have the problem primary clustering. Linear probing was the problem primary clustering, but quadratic is resolving this problem. So the problem of the linear problem that is resolved by quadratic probing. What is the primary clustering? I will make the separate video for the primary clustering as well as the secondary clustering, and how you resolved and how you resolved everything I will going to explain the separate video, because if I am going to explain here this video become the large one, so that I don't want. I will make the separate video, but I will give you the idea what is the primary clustering. I'll just give you the small idea here. So first I'll explain that what is the clustering. Clustering, it means that clustering means group. Clustering means group of element. So this is one cluster, or you can say that one group. This is one cluster or one group. This is the another group, right? So how many clusters here? 3 clusters, right? Here there is a 3 clusters. But if I am going to apply linear probing, if I am going to use the linear probing, what happened in linear probing? We were checking that immediate next is free or not. If it is immediate next is free, then you store. If it is not free, then check next immediate. If it is that one also not free, then check that next immediate. Like that you are doing in the linearly. So in linearly what you are doing is, suppose the collision occur at 0th index. Collision occur at 0th index, and this is your cluster. Do remember, this is your cluster already, and now the other element come. Suppose some other element come and there the collision occur, and that their index is 0. Then that element is also going to store here. If collision occur at 0th index, that element also going to store at fourth place. If collision occur at the 1 index, that also going to store at 4th index. If collision occur at 2, that's also going to store at 4th index. And if collision occur at 12, also going to store at 4th index. So because of that reason, this place is having high probability. Means what's the probability of here is that 4 by 10. Here the probability of the 4th index is 4 by 10. So either collision occur at the second, that's also going to store at 4th, and either collision occur at 12, that's also going to store at the 4th index, and this is called the primary clustering, and that was the problem of the linear probing, and that is resolved by the quadratic. Why so? In quadratic you are not immediate, you are not checking, you are checking the square wise, you are checking the square wise. So it's not mandatory that this 4th, you are not going to get that 4th, because their square value is some different, so there it is going to store. So this was the primary clustering problem that I'll explain again same thing with the proper example. So here I've just given the small idea about what is the primary clustering. And its disadvantage of the quadratic probing is that searching time is order of 1 in the worst case. And here quadratic probing resolve the primary clustering problem, but it has the secondary clustering problem. The secondary clustering problem. What is secondary clustering problem? So in secondary clustering problem, if two elements starting index is same, then it will get the same probe sequence. They will get the same probe sequence, and that's called the secondary clustering. That too I'll also explain. So just remember that if two element starting index is same, then it will get the same probe index, and that was the problem of the secondary clustering of the quadratic probing. Right. Next one is that there is another disadvantage also, saying that it's no guarantee of finding the slot. If half of the table is filled, it will not guarantee that the next element will get the slot. So in quadratic probing, there is a one more problem is that if your half of the table is filled, then it will not give you the guarantee that the other element is going to fill in the table. Sometimes what happened, the cycle come. Sometimes what happened, the cycle came. If you are going to do a square and a square and a square, so like that you will get that cycle. Cycle means what? You will get that, suppose one index is 1, another you are getting the third, and then you are getting the 4, and afterward again you are getting 1 3 4, then again you are getting 1 3 4. So this type of the cycle going to form. So what happened, every time you will get that this 3 index 1 3 4 1 3 4 1 3 4, and that is already filled. So like that the some element will not going to get a chance to insert in the hash table, and that's the problem of quadratic probing. So same thing he say that if the half of the table is filled, it will not guarantee that it will give you the slot. So this is also the one problem of the quadratic probing. That's all about this quadratic probing. I'll make that separate video for the primary clustering and secondary clustering, and how to resolve using the double hashing. That too I'll explain. Thank you for watching my video, and if you like my video, you can do subscribe, comment, and share with your friends.